Hello and welcome to a new Voltlog. Today I am building a heated seat pad. So if you live in a place where you don't see any cold weather all year long, then this might not make a lot of sense to you. I got this idea last winter, but delivery of the parts needed was so slow it took like 2 months or more. Spring came and it wasn't really needed to have a heated seat pad anymore, so I postponed the project until this next winter. Fortunately, things have gotten better with the postal service here, and now I'm receiving my packages much faster than before. There are ready-made heated seat pads or seat warmers, especially designed for the car seats. They plug into the 12-volt socket, but those are usually pulling too much current to make them easy to use away from the car or make them portable. And I always like getting into the DIY spirit by making something, so I am building something which is more suitable for home use. I plan to use these heating pads, which you can get off eBay for about $4 a set of two. They're designed to work at 5 volts. They even come with this USB plug, and that's one of the requirements of this project. I want it to work at 5 volts so I can simply power it from a phone charger, wall adapter, or simply from a power bank and have it portable. We will take a look at the current these things pull and see if they stay under or around 2 amps, which should be manageable by most power banks and wall adapters these days. You might find these heating pads under different shapes or different ratings. Feel free to play with those, but keep in mind that if you go over 2 amps or if you step the voltage up, things start to get harder to manage. Wires need to be thicker. For example, if you maintain the 5 volt voltage and you add more of these, you will need more current, thicker wires. I'm also interested how hot these things get, so I'm just going to connect them to my power supply at 5 volts and leave them running for about 20 minutes and or more and see how hot they get. So when they start cold at 5 volts, they pull about 2.3 amps. I expect that to change while they get hotter, because these are just some resistors dissipating heat, so they will have a negative coefficient, I suspect. So I'm expecting that current to drop as they warm up. And yes, we can see that effect on the power supply ammeter. The current is slowly dropping. So I had these running for the past half an hour or so, and the temperature has stabilized. It's around 40 degrees around the input of the circuit, and it drops about 10 degrees towards the end of the pad, and that's to be expected because let me get a flashlight. So if I shine a flashlight behind these, we can see we have 2 bars along the side. Those are the main connections, and we probably have some parallel wires between those bars. And what happens, you get some voltage drop across those bus bars. So towards the end, you get less voltage applied on those parallel wires, which are actually resistors, so you get less dissipation towards the end of the pad. So that's why there is this temperature gradient between the entry point and the end point of these. As we can see in the on the power supply ammeter, the current is around 2.3 amps. It hasn't dropped as I was expecting, but there are variations when you touch the pad or when you will sit on this pad, because the resistance of those wires inside is changing. So as you can see, I can change the current that these things pull, but it is within a range that a wall adapter or a power bank can handle, because those should be able to output up to 2.4 amps if they're good quality devices. 40 degrees Celsius is a nice comfortable temperature for my rear end, while towards this end where I get about 30 degrees. It's a bit colder, but it's going to work. I plan to mount a couple of these inside the seat pad. I think I'm going to mount them like this, have them parallel, so I'm going to have to remove these stitches. So this will be a first for me in my DIY projects. I'm going to work on these kinds of things. I'm going to be sewing with needle and thread. Like I mentioned, using two of these will result in a nice round value of current being drawn between 2 and 2.3 amps. If you plan to use more of these, consider 1.2 amps for each of the pads used. I'm also thinking it could be a good idea to replace these supplied cables with something a little bit better that would carry the current better, because these ones do get hot while running the system. In fact, let's get their temperature. You can see these wires, they have around 49, maybe 50 degrees Celsius. So they do get as hot as these pads, and that's a sign these are not very good quality wires. They don't have enough copper in there, so there is a voltage drop even on the wires themselves. And this is wasted energy. That energy could otherwise be put into the pads and heating you. I plan to have this thing always on maximum, so I will only use a simple switch, an on-off switch. But you could do this several ways. You could use an Arduino plus a MOSFET to do the switching of the power, and then you could have, let's say, temperature control by using a thermistor or timer control of the heating. I just don't need that level of sophistication with this project. I just need a heated seat pad that I can take with me. Safety wise, what you should be worried first is the power supply that you're going to be using. Using a good thrusty power bank should be the safest, but if you plan to use a wall adapter, then make sure you use a decent one with good isolation between primary and secondary. You don't want any high voltage accidentally going near your bomb. I'm going to use this one, which I got from Lidl. They're cheap and decent quality. I've done a teardown of this in a previous video, and it had good isolation between primary and secondary. Also, safety wise, you want to limit the current this thing can receive, just in case something goes wrong. In my case, by using a wall adapter, that's limited to about 2.4 amps before this adapter will go into protection and limit the current. So I don't need additional current limiting. The power bank also limits the current to 2.4 amps. But do consider this if you're using a beefier power supply. You might need to limit the current somehow. Also, something to note is that some USB power adapters or power banks won't deliver full power unless they get a certain sequence on the data lines of the USB plug. In the case of these heating pads, the cable they supply, the data lines are left floating, and the power adapter as well as my power bank seem to be happy with that and deliver full power. So before we get started on the actual project, let's take a closer look at one of these pads. I want to take it apart and see how it looks inside. First of all, let's check the resistance of this. So it's about 5.3 ohms in total, measuring right at the input of the USB socket. But this will change. Like we have contact resistance on this plug, on this one as well. It will also change if we play with the pad. So it's kind of difficult to judge this and get a value. It's around 6 ohm, let's say. But there's going to be a difference between measuring on this end and measuring on this end on the input of the pad, and that's what I want to show you here. As you can see, very fine wires. You can even count the threads inside this wire, and it's not very. It is flexible, but it's not nearly good enough for for continuous carrying of more than 1 amp. So let's check the resistors now, right here close to the close to our pad. So we have about 3.7 ohms. So the difference up to 6.5 ohms, it's all in the cable. So as you can imagine, we almost have a second one of these pads in the cable itself, which will have a voltage drop and will dissipate power. That's why we were measuring 40 degrees on the cable itself earlier, because it's dissipating almost the same amount of power as these heating pads. I'm curious to see if inside we're going to have something like some flat flex circuitry, some copper between Kapton layers, something like a flexible PCB, or maybe they use the different construction, but we can see a bit of that orange color that you get from Kapton tape. Okay, so I managed to pull this thing apart, and it's a bit different to what I was expecting, but it makes more sense now, because as I was thinking, if you run wires between these two rails, those wires could break over time and the resistance of the pad would change, so it wouldn't be a very good idea or solution. It would not last for a very long time. But instead what they're using is two pieces of copper tape along the side. Those are the bus bar connections, the main input, and between those connections you get this gray stuff which looks like graphite, judging by the gray color. It's conductive. There's some kind of it's maybe a powder, maybe there are some fibers which are spread on this cloth material, and that will have a certain resistance. Let me bring the meter into picture. So as I decrease the distance between my two electrodes, you can see the resistance decreasing. So it's a pretty nice idea because it's a flexible resistor. That's why it was changing value when I was playing with it, because you basically change the surface area between the two electrodes, and that changes the resistance. So it's a pretty interesting construction method for these pads, and I think they will last me quite a while. So I searched through my bin of scrap wires, and I found this cable, which comes from a MacBook wall adapter. It had some problems with the MagSafe connector, but this is designed to carry 4 amps or so, so it will handle our project really nice. It's about 1.5 meters in length, and that's about the size that I need. And I'm also going to take the USB connector from this old lightning cable, which also had some issues. It's white, it's going to go well with our cable. So I'm going to start by removing this piece of cloth tape that covers the wire connections. So I finished the wiring. They are wired exactly the same as they were originally, in parallel, but now I have this better cable for running current up to the pads, and as an effect of that, the resistance has dropped, and these are pulling a lot more current now. They're pulling about 3.5 amps, because I practically removed almost half of their resistance, which was caused by these thin cables that they were using. Right now I'm going to try to install them. This is about the position that I want them to be in. I'm going to try to attach them by stitching a couple of corners on each of the pads to the top surface of the seating pad. So there is a high risk I'm going to stab myself in the finger right now, but it's all in the name of science. So I did try to stitch these in, but it was kind of difficult to do, so instead I decided to glue them to the top surface of this cloth. I'm not really sure what kind of glue to use. I have a couple of different glues in here. Maybe I'll use this universal hobby glue. I also have some spray glue, not really sure what I should use here. So I think I'm going to use this multi-purpose adhesive from Tessa. I hope this will do the job fine. I'm going to place a few drops on the extremities in the corners of this pad. Let's place a couple in here in the middle. So the glue is going to be visible because I can see it going through the top side of this material, but I won't mind that as long as it will do its job and keep these secure. Here is how I wired the USB connector. You can see I have these very thick traces from the MagSafe charger, and they're soldered to the positive and negative of the USB jack. Then I'm going to put some hot glue in here and seal everything together. This should hold up quite well. So I finished sewing back together this seam here, which I opened previously to insert the heating pads. There will be some glue marks left on the fabric, but that's okay, that doesn't bother me. I could have placed the glue on the bottom of the pads and glue it to the foam inside. That would have prevented these marks being visible on the outside, but I don't think it would have held as well during usage. So here is how the seam looks after I have redone the stitching. The cable comes out through here. I think it looks pretty good, and trust me, I'm not good at all with this kind of arts and crafts stuff, but I think I did well for this project. I get about something over 1 meter of cable. This is our USB connector, but as a consequence of using this good quality cable, the resistance has dropped, and the heating pads are now pulling more current. For example, right now it's pulling 3 amps from this power bank, and I think this power bank is capable of supplying 3 amps. I don't know for how long, but this value will change, as we know. Like when I'm going to sit on this, I'm going to apply some pressure on the pads, and as you can see, the current will drop to about 2.5 amps while sitting on the pillow. I'm not sure how this will affect the pads. I'm not sure if they can cope with a 3 amp current and still survive. I'm not sure if the manufacturer of these pads has taken into consideration the resistance of the cables. I don't really think they thought that far when designing or when they made these. So I think they should be fine at up to 3 amps, but it might be a problem for your power supply. For example, if we are using this Lidl charger, this is only rated for up to 2.1 amps. And if you go to 3 amps, it will supply 3 amps for maybe a minute, but then it will go into thermal protection and it will shut down. If you use something beefier, this one is rated for 2.4 amps on each port, but they share the same DC to DC converter inside. So this one is in theory capable of more than 4 amps, and it will supply this heating pad with no issues. But that's just something to consider if you're doing this mod. You might encounter this problem, and it might be solved in a couple of ways. You either stick to the original wires, or if you change the wires, you may add a 2.2 ohm or a 3 ohm resistor in series with the pads, just to limit the current, but it's going to have to be a beefy resistor and it's going to dissipate power as well, so you need to take care of that. Or you might use something like a DC to DC converter and maybe lower the voltage, lower the total amount of power that gets to the pads. That way you lower the power dissipation. I'm quite happy with how the project worked out. For me, it's not a problem that it pulls more current. I'm just saying it so that you are aware of this issue if you're making something like this for your own use. So like I said, look, when I put some pressure, it's around 2.5 amps of current. I can get at about 2 hours of usage from a 5000 milliamp hour power bank, and that's more than enough for my needs. I initially wanted to build this because during winter, when I go fly my FPV plane, it's quite cold outside, and I can use something like this. I usually stay there on the fields for maybe an hour, so it's something like this and a power bank. I can keep myself warm while flying my FPV plane. Although there wasn't a lot of electronics involved in this video, I hope you enjoyed watching me build the project. If you liked it, don't forget to click the like button, because that always helps the channel grow. And as usual, there will be links in the description below for the items shown in this video. I'll see you next week.